The sum or difference of two perfect cubes can be factored using some soap and boxes. So what that means is, for perfect cubes, you will have two factors. The first factor is just what's being cubed. So for the first term, that's A, and the second term, that's B. And it's the same whether you have a sum or a difference. But the second factor is going to be a trinomial. There'll be three terms, and so that comes from the boxes. If you write three factors of each term because they're being cubed, so A times A times A, B times B times B, and then box those into pairs of factors, so two factors from those cubes, so that the first term comes from the first box. So A times A is A squared. The second term comes from the second box. A times B is AB. And the third term comes from the third box. B times B is B squared. So those are the boxes. So where does the soap come in? Soap tells you what the signs between the terms should be. So the first sign is the same as your original polynomial. So for the plus sign, that's a plus sign. For the minus, that's a minus. The O tells you that to use the opposite sign. So if there was a plus sign in the binomial, there'll be a minus sign there. If there was a minus sign, there'll be a plus, the opposite. And the last sign is always positive. So that completes the factors for the sum or difference of two perfect cubes. We know that this trinomial that we have is never factored further because of the pattern that it is. It doesn't work out. The factors it'll never be factorable. So let's use that soap and boxes to factor some perfect cubes. First, we want to rewrite them to identify what kind of cubes we're working with, and then we can factor. So, for the first example, we have x cubed plus 1 cubed. Those are the perfect cubes. So the first factor will be an x and a 1. The second factor, I'm going to write three factors of each and pair them up by 2. So the first term will be x times x, that's x squared. Second term, x times 1 is x. And the third term, 1 times 1 is 1. Then I'm going to put the soap in. So the same sign, this is a positive. Opposite is negative, and the last is always positive. Our next example, we want to identify what kind of cubes we're working with. So that first term is y cubed and 64 is 4 cubed. If you're not sure, you can take the cubed root of 64 in your calculator to identify what the cube root is. So now we can factor this perfect cubes. The first factor is just what's being cubed, y and 4. The second factor, I'm going to multiply y 3 times 4, 3 times, and take boxes of 2 factors each. So that the first term is y times y, that's y squared. Second term, y times 4 is 4y. And the third term, 4 times 4 is 16. So then let me put the soap in to complete these factors. Same sign is negative, opposite is positive, and the last is always positive. Some more examples here. We want to first rewrite the problem before we can actually factor. So let's identify what kind of cubes we're working with here. For the first term, that's 4y that's being cubed. And the second term, that's 1. So we know we'll have two factors here. The first factor is just what's being cubed, 4y and 1. The second factor, I need to multiply 4y times 4y times 4y, and 1 3 times, and It's good to put something between those factors so you can identify where to box them up in pairs. So then the first term is going to be 4y times 4y, that's 16y squared. The middle term is going to be 4y times 1, that's 4y. And the last term, 1 times 1, is 1. So then we can put the signs in, same sign positive, opposite negative, and always positive for the last term. Let's see if we can rewrite this next example. AB cubed will be A cubed, B cubed. And 2y is the cubed root of 8y cubed. So we can rewrite that, and then we can factor the difference of two perfect cubes here. So the first factor is AB for the first term, 2y for the second term. Then we need to multiply AB 3 times 2y 3 times so that we can box these up in pairs of these factors. Okay, so the first term, if we multiply AB times AB, that's A squared B squared. The second term, AB times 2 is 2ABY. And then the last term, 2y times 2y, is actually 4y squared. So then we can put the signs in. Same is negative, opposite is positive, and always positive for the last sign.